Now for this last session, I want to show you the various circuits that are available to you for most common components. Generally, we're talking about components that do not have pin descriptions. They are common components that we normally use in our everyday lab. From the beginning, as I mentioned before, you have to set up some type of power supply. Usually that corresponds to the top and the bottom. And sometimes your mic controller might need a reset switch to restart the program. So here's an example of how you would connect a reset switch to the microcontroller. And over here is how you might connect the power, VSS, VDD, and VSS. Because this is a complex chip, you will not need a capacitor circuit. Everything you need is right on the circuit board. We mentioned before that sometimes you have multiple power supplies, like this and this. Well, it's not economical to use two different power supplies for your project. Normally, when you buy electronic equipment, you only get one power supply. So there's something called a voltage regulator that allows you to take one power supply and create another power supply at a lower value. So you would only need one source of power. Let's say in this example 12 volts. Then you would supply the 12 volts through the 7805 and you instantly have 5 volts for the other part of your project. Moving on to input components. Here are some examples of some circuits you can use for switches. And the signal would come to your microcontroller from here. This is called an active high and this is called an active low configuration. Some of you might be using a potentiometer, which creates an analog type signal. This could go to an analog to digital converter, and then that could be then connected to the microcontroller. These are some sensors that changes ohms with light and temperature. So it has a varying output depending upon what the input is. And you can see these are voltage dividers. And once again, they output an analog voltage. And that will go to an analog to digital converter. These are some output devices that you might use for your project, such as an LED or a buzzer. Because the current in these two devices are so small, you can connect these directly to the microcontroller. You do not need a driver. You only need a resistor to help control the current. And these are some very common values to use for the components. Here are two common circuits that are used to drive high current devices, such as motors, lamps, relays, solenoids, and other high current devices. Generally, when you need current more than 25 or 30 milliamps, you would have to connect it to something like this. We do not have these in the college. We have some other components that are very similar to these two components. I believe it starts with the TIP. You can ask Ms. Afaf for the actual value. These are transistor drivers. You could also use a group of transistors like this to drive your motors. So here is an example of using this transistor to operate a lamp and a buzzer. And this is what will connect from your microcontroller. Here is an example of using the same circuit to operate a relay. And here's an example of using a relay to operate even a higher current motor. Now for devices like motors and solenoids, you also have another type of transistor, a MOSFET, that can be used to drive motors and solenoids. And again, we do not have these in the college. You have to check with Ms. Afaf to see what the equivalent value would be in our college. Here is an example of a circuit driving a solenoid valve. Usually this is connected to air pressure or water pressure to control the flow of water or air through a device. Here is a configuration using two relays that allows you to turn the motor in one direction or to turn the motor in another direction. Here is a microcontroller using a special chip to drive a motor in positive and negative directions. And as you can see, we have many examples of different types of components and circuits. Here is an LED 7-segment display driver. Some of you may have to connect your system to the PC, and we have these chips in the college that allows you to connect from your microcontroller directly to the computer. That's the end of this presentation. I hope you've learned something from this, and I hope this will be a valuable resource in helping you get started in building the final circuit diagram for your project. For components that uses pins, you'll have to study the data sheet to find out what wires are needed. In my final presentation, I will give an example of a component of this type.